Bonjour, bonjour, mes amis. It is delightful to be here with you this evening. It is delightful to be talking about aging with you, and even more delightful to be here with you, Justin. Good evening, sir. How are you?
I'm good. Good evening. I'm feeling young and filled with vitality, and I'm doing my best to keep it that way. And that's what we're talking about, right? We're talking about aging and that this whole idea of biological aging and that dichotomy between biological versus chronological aging. Like
Mm-hmm.
the number of trips that we've made around the sun is kind of an arbitrary number. We've chosen to label it as something, but what's going on in your body, that's the real rate of aging. And I think that's much more applicable to how healthy you are while you age, right?
Yeah.
Lifespan and health span together in one. What's better than that?
I have a working theory that time doesn't exist, and I value that tonight as we explore aging, we're just going to be proving my theory. So, before we get too deep into it, welcome, audience. The last time I saw you, I was in California. I'm back happily in Toronto, and I'm so curious where everyone is calling in from. For those that were here with us last time, we had someone who was calling in from a boat. We've had several people calling in from cars. So, my goal is to be getting someone calling in from a plane. So, audience, where are you calling in from? Please, someone tell me they're calling in from a plane. Certain life goals. I see some Californias. Also, I see some Californias. Um, Please do, audience, let us know where you're coming from. And ooh, we have London as well. Delightful. I like when we get more than one continent going. Yeah. Oh, Australia.
Australia. Let's go.
Really, really dipping down there. I love it. Yeah, we see some Californias, some Washingtons. Audience, it's so great to see you here. Thank you for joining us. Um, yeah, so uh, Justin and I are going to kick off. We want to start talking about aging and exactly what is it? Because I think, if we're going to take away the idea of aging is just a calendar, we want to talk about what exactly it is and how the body ages. Before that, though, audience, if you have your DNA 360, I'd encourage you to get it out, get it ready. Justin, I'll probably talk for about 10-15 minutes before we talk specifics in it, but it's sometimes helpful to have access to it so that if we talk about any genes, you can see them, you can see how your genes are showing up. Yeah.
Yeah, and it's really important to remember that, having the genes on hand, it represents that hardware that you can't change or do anything about, but we're also going to discuss it through the lens of epigenetics, right, which is more so the software and something that we can in fact alter, like we have all of these environmental cues that we do have control of, and
Mm-hmm.
those cues, be it nutrition and stress and toxins and things, they enter the epigenome, right, and they become methylated or not, and that really changes the phenotypic expression that we end up with. And the phenotype
Mm-hmm.
is how you live your life through, right? That's the real representation of your body. So know the genes, but then, of course, we're going to add in the proper interventions to make sure that we're getting that high quality methylation pattern so that you're aging, hopefully in reverse.
Yeah, I love that. Mike said International Space Station and then ruined it by saying just kidding. So, Mike, I value you until you said just kidding.
Good effort,
But
Mike.
Sue,
Good effort.
yeah, Sue might win. Sue's calling in from Maui, and so I think Sue wins the crown tonight. All right. So, Justin, let's start talking about how the body ages. Because I think this is something that, it's one of those things, when a child comes up to you and says, like, why? And they ask a question of why, and then you're really forced to think about something, and you're like, I have absolutely no idea. This is kind of what science did maybe 10, 15 years ago when we really started to try and define what exactly is aging apart from a number on a calendar, right?
Yeah.
Yeah.
Yeah, and it's really the technology that we are afforded now has come a very, very long way. Like when they really first started making some of these methyl clocks and these different ways to try and quantify the aging process, it was a lot less advanced in those first generation clocks. And now we have what, second and third generation clocks, which really are
Hmm.
measuring some of these things called CPG islands. And you can actually see what is being methylated on average and what is not being methylated on average. And remember that the more that a gene is methylated, the more that it's turned off, right? So
Hmm.
we're really looking at that expression and how it really correlates with these proxies, they call them, right? So you can actually look at methylation at the level of the DNA, and you can see what genes are regularly being expressed or rendered dormant. And it's got such an impact as to the actual functioning of your physiological systems that it's a pretty interesting thing to be able to look at with typically just
Mhm.
a little bit of blood, on a finger stick. It's a pretty cool
Yeah.
thing.
It is neat. Audience, I'm getting a bit of feedback that the difference between mine and Justin's voice is a bit tricky. So I've moved the mic closer. Let me know if that's helpful at all. I know I have a bit of a softer voice than most of our presenters here. So before we get into how can we measure aging, I want to meditate on some research that has come out in the past 5-ish years, and really talk about how people age, right? So before we even get into how do we quantify it apart from a calendar, let's talk about how people age. Because we used to, or at least the working theory for a long time was that aging was this linear process. It was a straight line that, as you got older, your body kind of at the same rate was aging. And over the past 7 or so years, there have been a number of studies, many headed out by Stanford, so shout out, that have explored that we actually don't age in a linear fashion, right? An equal across all time fashion. Instead, we're tending to age in bursts, right? And there's a few proposals out there as to when these bursts are happening, but right now where most of the research is kind of sitting is that there's going to be a burst in your mid 40s and then another burst in your 60s. Okay? Meaning, over time, yes, do you see changes in bodies? Do we see some wrinkles? Do we see a little bit more joint pain over time? Sure. But at those 2 points, mid 40s and then again in the 60s, you're going to see a lot more of the metabolic or impactful change that lends to kind of what we would call an older body. Okay. So how did they come across this data? I think it's really neat. It's still on the smaller scale because of how intensive the research is. But what researchers were doing is they had a group of people, depending on the study, it was usually around 200 people. And every year they would have these people come in, and these people would have gajillions of blood vials taken. And what the gajillions of blood vials were monitored for was it went beyond your standard blood work. They quite literally look into all of the metabolites within the body. And so, for awareness, when we talk about metabolites, think about when you drink alcohol. Alcohol comes into the body, your body's going to break it down. And that breakdown process, you're creating metabolites. So, what they would do with this blood work is they would analyze all these different metabolites from the breaking down process. So, we'd look at breaking down processes of alcohol and drugs, of fats, cholesterols within the body, of sex hormones, of growth hormones, every sort of metabolite. And they would analyze this over decades. And this is how they came across. They were saying, hey, both men and women, there interestingly wasn't much sex differentiation here, which to me is very interesting. Both men and women would show a marked change in some of these metabolites in their mid 40s and then again in their 60s. Okay, and there were two main patterns. So when you were talking about in your mid 40s, sorry, there would be a lot of changes in how you metabolized or dealt with your fat. Okay. There was also a lot of changes of how you dealt with alcohol. There was a lot of changes with how your cardiovascular risk was, meaning early 40s, you're doing pretty okay. Late 40s, there was a marked shift, and that's where you started to see that uptick of cardiovascular risk, right? There was also in your mid 40s, that's when you started to see, I love Justin uses this word, sarcopenia, which is a loss of muscle mass. Okay. And then this was also where you started to see an increase of fat accumulation. You also saw more marked changes within the skin, less ability to recover. That's kind of, where the fine lines went more into hardened lines. Okay. And again, every person's going to exist on a different continuum. Some people might have this tick early 40s, late 40s, but on average, at least within people studied, this is when it was. And then the changes for the 60s, this is where you saw more marked decline in immune function. Okay. So ability for body to be resilient against all kind of the pathogens and toxins and critters that creep in. There was also an increased rate of sarcopenia, so loss of that muscle mass. And remember, it's the muscle mass that really keeps us happy and healthy and mobile, right? I see Justin nodding because when we talk through blue zones, like your quad size, your quad strength is a big, big indicator. Okay. This was also the point where we started to see decline in kidney function, right? Which is one of our stronger detox systems, okay? Kidney function, as well as how you were processing your carbohydrates. So we lost some of our fat or lipid processing in our 40s. In our 60s, we started to see that extending out towards carbohydrates. Again, this risk of diabetes and insulin. And we're going to talk a lot about how sugar influences aging, okay? And this was also the point where we started to see a lot more of the metabolite evidence of chronic disease. Okay, so think through cancer, think through heart attack and stroke, think through kind of chronic inflammation, that sort of stuff, heart health. Yeah. So, um, Justin, I have a question. We both know the answer to this, but play. Let's do a little vignette, a little skit here. Do scientists describe this to something that's just inevitable? It's something within our biology, something within our DNA that's inevitable. We don't have control over it. Or are they more ascribing this to lifestyle, to how we live our life?
First of all, I love that you think I know what the word vignette means, but I can guess. Um, I
Milestones.
would say it's a combo, right? It's a
Yeah.
combination of both. I mean, nature, people like to say nature versus nurture, but I think that
Hmm.
the successful marriage of those two things is what actually lands you with what you land with, right? Like we talk
Hmm.
about that all the time. Like if you have suboptimal, let me use an example, GSTP1 gene, okay? So that's associated with respiratory tract detox. And then that's nature, but then you also, the nurture side of it is you live in an area that has a lot of, smog, or you use too many toxic skin products and you're breathing it in all day, and hairsprays and what
Hmm.
have you. Well, that's the combo of nature and nurture kicking off a suboptimal result. You know what I mean? So, I mean, my brain immediately goes to it's kind of both. Like, I think that there's a
Hmm.
naturally occurring element that's unavoidable. Yes, your hormones are going to slow down. You're going to retire from work, and maybe you have a little bit of angst because you feel a little bit of purposelessness there. All of these things together do matter. But then it's
Yeah.
also like, how are you living? Do you know enough about your body in the first place, what it likes, what it doesn't like? And there's ways that you can improve some of these issues, right? Like, for example, fatty acid metabolism. I mean, we know that there's a lot of ways that you can, in fact, help that along. It might be some
Hmm.
L-lipase. It might be paying attention to your liver and your bile flow and that whole, hepatic portal system and how that all goes. Carnitine and ketones and fasting and workouts. And I mean, there's always something you can do about it. But to answer your question, I would say it's both. What do you think?
Yeah. Where scientists landed in it, and I value how humble they are. They kind of started off with, yeah, it's probably within the body, but they actually landed with if we're seeing these differences across sexes, et cetera, there's probably also a huge lifestyle component. So they don't have a firm answer. But what I was reading in kind of the discussion sections of the paper, this is where scientists go back and forth and like, why? You know what? This is where they get to be creative. They like you landed at there's probably a combination of both items, and the beautiful proverbial silver lining of that is if it is a combination of both, knowing genes and how you exercise those within your life can have impact and will have impact, right? And so I want to, Justin, I love if we can transition because I think you so beautifully set us up and to discussing how we can measure aging. How can we actually know how you're aging relative to calendars or times around the sun? But before we do that, Vanny, if you would please toss up our poll questions. So, audience, what's really important to us, what Justin and I show up every time for, is how do we support your learning and understanding? So, to that end, we always ask poll questions at the beginning so that we know why you're here and ensuring we speak to that throughout our webinar. So the first question we asked audience, and I love this answer, we said,
Amazing.
how would you describe your current approach to aging? So 82% are working towards the end of aging really well. And I don't wear hats, but if I did, I would tip it to you because I love hearing that. That's delightful. 8% was very honest, and I value this. They say they do what they can, but it's not their top focus. Love it. 8% is also just saying, I think aging is happening to me. Some days, absolutely, I'm in that boat. And then 1% is saying, I haven't thought about it. And I'm grateful that you're here, and I'm grateful that we're starting to spur some of those thoughts. We asked, what do you believe has the biggest impact? Diet and lifestyle, genetics, environment, and 81% of the audience said combination of all three. So Justin, they're happily in your camp, my camp as well. That kind of acknowledges it's a happy little mixing of all. The next question we asked is, have you done a genetic test before? A majority of our audience has done ours. We're grateful for that. 13% is saying other providers. I'm seeing a few points in the chat where people are like, hey, can you leverage information from other providers? The answer is probably. We do have an app. We will link to that app in the chat. If you download that app, we are able to ingest 23andMe files and translate it into what we know. It won't be a perfect matching because our analytics of the genes go a little bit beyond 23andMe, but you'll still be able to get some really useful information. So look in the chat, get that link to the app, and then you'll be able to leverage some other companies' data within ours. Okay. The last question we asked here, and this is really important, is what aging matters, what aging concerns matter most to you? And there's a happy smattering here. If I'm going to just go with the top four, the top two are longevity and disease prevention and energy and fatigue, which I love that because I think those go hand in hand so well. Why live long if you're not going to enjoy it and have energy for it? The strong third place is going to be brain fog and memory. Yeah. 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 Yeah.
So
Good.
common, right? I mean, that's like there's a lot to do with mitochondria and things going on there, but that's definitely like I'm encountering that more and more. And I think that that's one of those things that we associate with aging as well, right? Cognitive decline, and there's certainly some
Yeah.
genetic elements to that. So a worthwhile endeavor to make sure that we're counteracting that so you stay sharp all the way through to the end.
Mm. Yeah. Yeah. Because I think especially with modern medicine, we see evidence of it more than we ever have before because we have capacity to support life, perhaps often once the mind is gone past a strong point. And so I think to myself and my mom, I watched my grandmother who had marked dementia, right? I watched her for 10 years. And so I saw that. And I'm grateful for the time, but I can also appreciate how fear-inducing that can be because I would not want to spend my last 10 years in that way. Yeah.
Yeah.
Yeah. Yeah. So um, let us, audience, next I want to talk about how we can measure your actual age outside of a calendar. And I'm curious, audience, toss into the chat if you've done any of this. Jess and I are going to explain it, but if it's a test you've already run, you probably already know about methylation testing. Let us know on the chat if you've done any of this aging testing and what your calendar age was versus what your, I'm going to call it DNA age, for lack of better phrasing, what your DNA age was. So, Justin, talk to us a little bit about this. What exactly is this methylation testing, and how can it dispel my belief that time doesn't exist, or
So
support it,
this
I guess.
is it's a cool concept. I really like it. And it's really the other side of the DNA 360, right? So epi is actually a Greek word. It means above. So we've got your actual baseline genetic blueprint. I say that it's like written in pen, but the epigenetics are like written in chalk over top of it. And you can actually erase them and you can write again. The cool
Yeah.
thing is that if you write the same thing in chalk enough times, you'll
Mm-hmm.
notice that when you go to erase it, there's just a little watermark, like there's something on there that you can't quite erase. It's still there. So that's my convoluted analogy as to a
Oh,
methylation
that's great.
pattern, right? If you have the same input over and over again, over top of the genetic blueprint, you start to create a pattern. And next thing you know, you're looking at the blueprint. You can only really read what's on top, the most superficial layer. Remember, this means above, epi. So your cells are reading the blueprint and they're behaving accordingly. But
Mm-hmm.
if you write in chalk over top of it, they can only read the chalk, right? So the cells are going to behave based on what that epigenetic expression looks like. And what's crazy to think about is that, like, every cell in your body has the same DNA. It's just the epigenetic expression that gives it that identity, right? So when we're looking at these epigenetic regulation channels, we're really having an understanding of how the cells are going to express. And we can measure it by looking at these, like I said, CPG islands. And it's actually
Mhm.
looking at what's being turned on and what's being methylated and therefore turned off. And from there, AI is so incredible that it can actually extrapolate and get all kinds of different proxies, including like CRP estimations and some of these more traditional plasma based biomarkers. You can actually get a DNA methylation estimate of it that's actually even better and more
Mhm.
actionable because it's very much recent. So,
Mhm.
among the reports that we look at, we're partnered with a company called True Diagnostics, and they did a lot of work with Harvard. They did a lot of work with Yale. One of the main ones that's relevant for this
Mhm.
topic is called Dunedin Pace of Aging. I'm sure I'm pronouncing that right. It's spelt kind of odd, Dunedin Pace. But that's going to be the most like right now actionable, like this is your rate of aging. And ideally, what
Mhm.
we're looking at is how many years per calendar year are you aging? What's that sort of rate look like? Well,
Mhm.
you would think 1 year per year is what you're actually aging at. But if there's a lot of suboptimal genes being expressed and different things, you could be 1.01 per year,
Mhm.
right? So
Mhm.
that just little acceleration is enough to increase the likelihood of any number of chronic diseases. What we want is like 0.99, 0.98. If we can reverse it such that you're aging at a slower rate than 1 calendar year per year, then you're
Mhm.
actually aging in reverse to an extent. And they actually have this thing called the Aging Olympics. Ben Johnson's all up in it, and it's like who can age the slowest in the whole world.
Mhm.
That's actually a thing that they do. So that's Dunedin pace, and it's going to be really relevant for like modern, like what are you doing right now? How's your body aging? Then there's
Mhm.
other stuff that they look at as well, like telomere length, which is an interesting one, right? Because that used to be a little bit more kind of the standalone biomarker a lot of
Yeah.
people would have
Yeah.
looked at. I don't know if you want to dive into that a little bit as to whether or not that's legitimate, Dr. K.
No, I'm happy to because I think it tells the story of how science has tried to understand aging, right? Remember audience, I said, science is really in more of an intelligent way only been digging into this recently, and telomeres were our first effort. So when we think about DNA, we have our happy long strand, and at the end there's something we used to kind of call a buffer region. It'd get clipped off a little bit every time DNA was replicated. And so the idea was the longer your telomeres were, the less they'd been replicated, the less stress there was, the younger they were. And so they would just kind of measure the length of that buffer region. And now what we've learned, and this was a gold standard, I would say 10 or 15 years ago, don't hold me honest on time, but in that range. And now it's not really looked at in the same way. And the reason is we found that there can be some enzymes that actually add length to the telomeres. So it's not always being shortened. Sometimes it's being added to. And separate to that, it is also influenced by a few other metabolic markers. So it's not always a true rate. So it's kind of like it gives you a general area of how you're going to be aging, but it's not very specific. Whereas this new technology that Justin's referring to, this methylation pattern analysis, a lot more specific. So, for example, the din paste, whatever he
Dunedin.
said, that one, yep, that one, that one can be very strongly correlated to, and this sounds very crass, but it can be strongly correlated to risk of death. In particular, if you have a number that is over one, depending on how much over one, that can be very strongly correlated to risk of death. I think it's within the next 5 or 7 years. I forget which number that is, but it's a strong indicator of risk of death. Now, I saw within the comments, especially since I kind of tossed that big scary thing out there, can you change this? Right? And the answer is absolutely yes, you can, right? So Justin leveraged, and I love this analogy, Justin, I'm going to borrow it. This idea of chalk. You can absolutely rub chalk off the board. There's an element, I think, he did, and I think this is valid. If you've put enough chalk on, there might always be an echo, but you can sincerely and definitely change this. And so there's a lot of people that leverage this sort of testing in order to track their aging. So they'll get the test, they'll understand how quickly they're aging. We haven't gotten into kind of the further analytics that will speak to what organ system within your body is aging, but you can find that out. Justin, maybe if you want to speak to that in a second, but we can look at what exactly is aging you. And then you can come back 6, 12 months later and retake the test to see how those patterns have changed. Justin, do you want to speak a little bit to the organ systems and how we can peer in through that blood sample, through those metabolites of what is actually creating the aging, be it quickly or slowly?
Yeah, so we've got these differences, in longitudinal measurements versus ones that are a little bit more kind of current. So the Dunedin pace is cool, and that's one that you would kind of continue to do because you can see what it's doing, and hopefully we're moving the needle in the correct direction. Some of these
Mm-hmm.
other things, where if you go for it's the DNA Aging Premium that we have, and by the way, I believe we do have a discount code on a 10% on right now, 10% off rather. Um,
Mm-hmm.
and that would also get you access to something called Symphony Age, which gives you really these indicators as to individual facets of aging, right? So it's not just like, how's my body aging? It's like, how is my brain versus my kidneys versus my lungs, right? Versus the respiratory system, the hormone system. How are all of these individual elements actually aging within my body? That's great because that allows you to really guide what your treatment would be, right? Like if we know how,
Mm-hmm.
this system is more compromised than that one, then of course that's a system that's going to require a little bit more reinforcement. And I love the connections between this and the DNA 360 because there's a
Mm-hmm.
lot of them, right? Like if we look
Mm-hmm.
at the DNA 360 and we recognize that what was written in pen originally, there's a red flag right there. Then we measure what's written in that chalk with the methylation test, and you can actually see your body's kind of history of aging within some of these different organ systems that they're looking at, and then you know what
Mm-hmm.
really needs to be done. So it's an
Yeah.
upstream versus a downstream conversation. And they also have a thing called omic age as well. And that's really like the historical aging of your body, like up to this point.
Yeah.
So it's a cool indicator because most of us have lived a little bit differently throughout different periods of our lives. Like how many of us were totally reckless as teenagers with our health, even as kids before that? I mean, I'll tell
I
you,
would hope so, a little
I
bit.
was not this way, right, forever and ever. I wasn't always a biohacker. I was way crazier and more recluse. So I can see what the actual like damage I may have done is based on that. And then we look at the Dunedin paste to understand, well, yeah, but in the last couple of months, I've added some high quality
Yeah.
interventions and look at what's happening now, right?
Yeah.
So between it all, you get this incredible picture of how your body's actually aging, and then you get to keep track of it as well. If you just do the
Yeah.
Dunedin pace, in and of itself, once a year or whatever it is, to
Yeah.
see what your interventions are doing.
Yeah. Yeah. I think as a practitioner, right? One of the more exciting groups of people that I get to see are people are like, "Hey, I'm really well. I just want to stay well, and can I get better?" They're such a fun group of people to work with. But there's always this element of exactly where do you start with that? Because if the person isn't reporting anything that isn't like, if they're like, everything's great, I just want to keep doing better, right? The question is, where do you start? Where do you actually create meaningful impact? And I find, to your point, between the two tests, that's really your starting point to know genetically what you're susceptible to and then what's actually showing up in your world. Because genes aren't destiny. And I think I want audience you to hear that again and again, right? Genes are not destiny insofar as having genes that say, you have poor cardiovascular vasculature architecture. That doesn't mean you're destined for a heart attack or stroke, but it does mean you have to work all the harder at it. And that does mean checking in as well, with various tests of, blood tests, et cetera, of how is cardiovascular system faring against all of
Yeah.
this.
Well, but that's the thing though, right? It's the devil is so much better than the devil you don't know.
Yeah.
Like it's such an interesting phenomenon I've encountered with people who have hesitance towards getting their genes done. And I
Mm-hmm.
know that a lot of areas there's cybersecurity stuff, not with our company, but with other companies. We put a lot in place to make sure that data is secure, et cetera.
Mm-hmm.
But people sometimes just don't want to get their genes done because they don't want to know that red flag. It's like it causes a
Yeah.
lot of anxiety in people. I
Yeah.
view this as more of an empowerment process. Like once
Yeah.
we know the devil, well, now we can fight him, right? So it's like, in the poll, one of the answers was like, I feel like aging is just happening to me.
Mm,
It's like
mm,
there's two different types of people in the world. There's people that things happen to them, and then there's people that go out and happen to things, right?
Yeah.
Like I really try to make people be that kind of individual that happens to things, because that gives you all the power in heaven and on earth. And we have the fortunate, right? It's very
Hmm.
fortunate that we have technology and things that can actually guide us in the right direction in
Yeah.
2025.
Yeah. Yeah. So I wonder if we shift gears just a little bit, because I want to explore. So if we know that, in mid 40s, 60s, we will likely go through some sort of aging burst, and lifestyle can influence that, possibly attenuate it, make it a little bit less. Um, I wonder if we can explore within the DNA 360, right? Different modules that we'd want to jump into. And so I wonder if we focus on cardiovascular and diet and metabolism, because as I went through, what are the changes, right? We know that in the 40s, we'll see changes in lipid metabolism, we'll see changes in cardiovascular risk. So, knowing that sort of stuff, how you are able to prepare for that, or in the 60s, right? Immune system, muscles, kidney function, carbohydrates, being ready for that to a certain extent, I think is really important. Yeah. So, Justin, where would you start? Someone comes up to you, they want to blunt aging at either mid 40s, 60s. Where would you start?
Gosh, it's like, where wouldn't you start? Because there's so much connective tissue within there. Like
Yeah.
an interesting thing would be like within the DNA 360, like we look at in the cardiovascular section, the nitric oxide gene.
Hmm.
There's actually a couple of them, but we look at one that's more like enos, they call it, because it's specified to the endothelium, right? Which is really important for cardiovascular health. And when we look at that and we pair it with the fact that nitric oxide production also, this is the nature and nurture thing, it also tends to slow down anyways as we age, right? So we get a little bit less circulation. Nitric oxide helps with all kinds of nutrient delivery as well as blood pressure, right? It also helps with things like vitamin D being released from adipose tissue in the body. So if we were to look at that gene and say, well, this is a suboptimal genotype, and then we know that aging is just in and of itself going to slow this process down,
Hmm.
to me, that's one of those areas that we want to work on. We might want to add
Yeah.
in some nitric oxide precursors, some red light therapy, some sun tanning, some exercise. So that's a really important gene, I would say. And, that pairs with things like the APOE gene, things like the 9p21 locus. I mean, this is getting into those weeds right now. Uh,
And I would also pause you. That also pairs well with a pleasure and a reason within life, right? Which is nitric oxide influence a lot. That would pair well with why you want to keep kicking around on the world.
Well, not to be inappropriate, but sexual function obviously requires blood flow, right? That's one of those
Mhm.
things. I would
For
argue that
men and
everything,
women, not just
men
men,
and
men
women,
and women.
absolutely,
Yeah.
everything requires blood flow too, right? I mean, you're talking
Hmm.
about the quality of your thoughts. Like the reason why we somewhat inappropriately call the ApoE gene the Alzheimer's gene is really because it has so much to do with calcification and the slowing down of blood flow throughout the body, including the brain, right?
Hmm.
So if you have calcification and it starts to restrict your blood, you're going to have neuroinflammation start to come later on because you're not getting as good blood flow to the brain, for the entirety of your life. So it can lead to certain things. I don't really like when people call this gene and that that gene. Uh,
Hmm.
but all of these things operate as a map, and nitric oxide, the ability to get blood flowing, is going to help with all kinds of things, movement quality, et cetera, as you
Hmm.
age. So I mean, what
Yeah.
area doesn't it impact if your blood flow starts to slow down?
Yeah. No, I love that. Oh, good and good synthesizing, because I think ApoE, given especially how um, intent our audience is on preventing cognitive decline, knowing ApoE and then really acting in support of that is really important. Yeah. I'd also, audience, want to draw your attention to within the cardiovascular report. It's technically not a gene, it's technically a location within the genome, 9p21, as in 9 Peter 21. And this is, we look at three different SNPs. And so, again, audience, think of a gene or a location kind of like a book. And remember, all pages in a book are not created equal. Some pages have plot points. So, we're looking at 3 pages in this book that really, really, really tell us. Oh, Napita's here. She says hi. That tell us our cardiovascular risk, right? Hold on, I'm gonna take a step back. It's going to be a bit more specific to the inflammation that occurs within the cardiovascular system. And the greater your risk for that sort of inflammation, the greater in the increased likelihood of a cardiovascular event like a heart attack and stroke. Right. And so, if we know in the mid 40s, you naturally, regardless of genes, are going to start tipping over there, it becomes really important to know your 9p21 status, because if you are someone with an unfavorable status, right? So if you're looking at your report, if you have between 4 and 6 G alleles, G is in Gregory, so 4 to 6 G alleles, you're in a position of being at greater risk for cardiovascular inflammation and therefore greater risk of a cardiovascular event. It really would serve you to the end of being mindful, working with a doctor, working with a practitioner. How do I reduce this cardiovascular inflammation? For people with that presentation, the 4 to 6, unfortunately, they're looking at almost a 1.8 increased risk of cardiovascular event. So if we know mid 40s, that's going to bump already up. We really want to be working towards the end of supporting and preventing that. Yeah.
Yeah, well, and I think too that when you look at that and the risk factor that that presents, your next question right there would want to be, well, where is inflammation coming from in my body as well? And
Yeah.
that's why each and every one of these elements of the DNA 360 is connected to the next, because
Yeah.
we can zoom out on that and we don't ever zoom in and just say, well, this gene equals X, and that means that you have this disposition. Sure, but it's a map and everything connects to the next thing. So if you have that, you have the 4 to 6G and that 9p21 locus, but you also have a lot of detox problems. You don't,
Mm-hmm.
utilize vitamin D very well. I mean, your genes indicate a lot of these different things. If everything else was totally optimal, it is still less of a risk factor just to have the 4 to 6G, because what's causing inflammation and how are you living your life? Like I always say, and I'm sure I stole this quote from somebody, but I say, show me your habits and I'll read you your future, right? If you live a great anti-inflammatory lifestyle, that's the best thing that you can do if you have that 4 to 6G and the 9p21. When we have these genes that are suboptimal and then we write in that chalk all of these inflammatory signals because we smoke and we don't eat well, et cetera,
Yeah.
that kicks it off so much quicker, right? What is the saying about the loading the gun? And you can probably say that one better than me, Dr. K.
Pacifist. I think genes load the gun, but lifestyle pulls the trigger. I
Yes,
think
that was
is
it.
something.
Yeah.
Yeah. Yeah. Oh,
The
I love
input,
that.
right? I mean, you're in control of the input. Once
Yeah.
you recognize the red flag, you have to double down on that input now,
Yeah.
because the epigenetic expression is the only thing that you have to control there. So I recommend you control it with all your heart.
Yeah. Yeah. Why don't we dig a little bit in before we shift into questions and answers? I want to make sure we touch on the metabolic side of it all, right? Because we saw in the mid 40s, again, fat lipid processing goes a little bit. And then in the 60s, carbohydrates quickly follow. And so, why don't we jump into our diet nutrition section and talk to TCF7L2 and ApoA2? Justin?
Yeah, gosh, TCF7L2, when that's dysregulated, it represents that insulin mechanism that exists in
Mm,
our body being dysregulated before you even ate anything. Like this is a gene, so it's something that you were born with. So some people, and we all know them, people that just struggle with weight gain, and it's like, I am eating the
yeah.
right amount of calories and things, but it's like, why is my body
Yeah.
just seem to be in storage mode all the time? And I'll tell you,
Yeah.
TCF7L2 is one of those contributing factors,
Hmm.
because it makes it so that it's harder to regulate blood sugars and things. And when that's dysregulated, just your macronutrient structure is harder to deal with. Even if you have optimal fat processing genes, which is the APOE2 gene, but that TCF7L2 gene is off, you can still end up with blood sugar fluctuations, even based on a pretty ketogenic meal, right? Just
Mm-hmm.
the volume of fat. So when I'm working with somebody and I see that that's off, that's one of the first things I look at with regard to the diet conversation, because it lets me know how much harder it is going to be to actually get their
Mm-hmm.
macros on point. To where I rarely recommend like a full ketogenic approach or like a higher
Mm-hmm.
fat
Yeah.
carnivore approach or anything like that with that dysregulation. And oftentimes you have to add in a few extra interventions like some good apple cider vinegar and Ceylon cinnamon and maybe some cold exposure that can even help, believe it or not, with regard to blood sugar, cortisol regulation, all the blood sugar stuff. You have to end up doing that because dysregulated blood sugar is one of those aging factors, in my opinion. Do you agree with
Well,
that?
it is.
Sugar is
Yeah.
definitely a big factor. Yeah.
Yeah. Yeah. Absolutely. Absolutely. And I think that's to the end where you see a lot of fasting protocols and other protocols that not only reset gut and immune, but also to a certain extent reset pancreas in terms of insulin secretion. Blood sugar regulation is an incredible and important part of that. Yeah. Yeah.
Yeah.
I've seen a few protocols of people who are kind of pre-diabetic and they were able to, and this is something you have to work with a doctor on, but they were able to leverage different fasting and ketogenic protocols to kind of reset pancreas and reestablish what is normal blood sugar. And so it's exceptionally important. Yeah. And I'm looking in the comments, and Denise offered a really interesting comment insofar as that when she looked at her DNA 360, she found out that she was non-celiac gluten sensitive, and also had endothelial issues. That's the 9p21 that we talked about a little bit before. And so her cardiovascular risk was kind of in a way that you wouldn't, or needed to be addressed in a way that you wouldn't have expected it, right? Looking at wheat and gluten and how that influences health questions, as opposed to the more obvious cardiovascular candidates. So thank you for sharing that, Denise. That's interesting.
Yeah. Hmm.
Yeah. All right. Shall we jump into the Q&A, Mr. Justin?
Yeah.
Do you have any other Justin bombs that you'd like to offer the audience before we get into the Q&A?
You
Justin,
know
for our
what?
audience, he's my favorite when it comes to all these Justinisms. He's always dropping the wisdom.
I have one more topic, not necessarily a Justin bomb. Those tend to come a little bit more sporadically. But you mentioned fasting there, and I do
Mm-hmm.
think that when it comes to this idea of aging, a lot of it does come down to some of these dichotomies between like feast and famine cycles.
Yeah.
We don't operate in the Keiko realm, right? Like calories in, calories out in and of itself. However, energy balance, I do believe, is actually a pretty big factor when it comes to the quality of your aging and how your body is aging. So, a lot of healthy aging, in my opinion, has to do with this relationship between something called mTOR and something called AMPK, right? AMP kinase. This is that direct example of feast and famine. We've got
Mm-hmm.
anabolic mTOR, right? Building tissues. And then we've got catabolic technically, but we have this clean out, fast cycle called AMP kinase as well. And so when we eat all the time and we have a surplus of calories all the time, we're stimulating mTOR, right? It's like we're encouraging growth of the body, growth of the body. We can't just do nothing but grow physiologically like that because other things can grow too, right?
Mm-hmm.
Tumors can grow, cancer can grow. We want to balance out mTOR activity with AMP kinase activity. And I know a lot of people reach to, the metformins and the rapamycins of the world. And I do think that there are some fasting mimetics like spermidine and things that do have some pretty good properties to them. But just having that's what I mean when I say calorie balance, right? It's like it's not something where you pay a personal trainer a bunch of money, he plugs your weight into the app and he gives you a calorie count. It's more like we want to give homage to these feast and famine cycles that our ancestors just got defaulted into because food wasn't just available everywhere.
Yeah.
You know what I mean? So
Yeah.
AMP-K would really help trigger that clean out
Yep.
process in the body. And then we would get a big protein, dosage and it would initiate mTOR. And that really was a big regulator of longevity for a lot
Mm-hmm.
of people. So just an added food for thought thing there, pun intended.
Yeah, I value that you bring that up. And I also value that you kind of really position that in terms of fasting. Um, because I think, to your point, while the metformins of the world have a place, when you embark on a fasting protocol, and it's appropriate, right? You should validate with your doctor, all that other fun disclaimer stuff. There's so many other benefits that go beyond just even this mTOR pathway that Justin spoke to, right? By depriving gut of food for a while, you're able to reset your biome. You're able to reset a lot of the function down there. And we know through so many webinars how integral immune and gut function is to how you feel, to how your body functions, to how your body navigates experience of the world. And so really do hear what Justin is saying in this I will still offer it's a truth bomb, it's a wisdom bomb. There's some things you can't kind of just pill your way out of. You truly do need to take on that diet and lifestyle change. And I'll say for people who aren't familiar with fasting, it's, the first time you do it, maybe the first few times you do it, you may not like it. You may hate it. That was my experience. Um, but after that, right, it becomes to a certain extent something you become addicted to because you understand what your body's going to go through. And then you get ready almost for that high. It's kind of like running, right? I think runners are crazy. Good job for you. Don't understand it. But they always talk about that runner's high. If you train, training's difficult, but the more you train, the more you're able to reach that high that feels really great. So good job, runners, but I'll fast over here.
Yeah, same here.
Yeah. Good job, runners. Okay. Shall we jump into questions and answers?
Yeah, I'm ready for it.
All right. I love it. And audience, I'm seeing quite a few people tossing like pretty intensive questions into the chat. It's difficult for us to keep up with them there. So if you have a more intensive question, please do put it in the Q&A box, because then we'll be able to see it and actually pay it attention versus trying to scroll back and forth through the chat because we get a lot of activity on the chat. And so a lot of things do get lost in there. So audience, if you put a question into the webinar chat, just copy and paste it into the Q&A so that we can actually attend it. I don't want to neglect anyone unintentionally on this. All right. So Christina, hi Christina, she's asking what are the CPG islands? And so Justin, do you wanna I see you nodding because I think you brought it up. Do you want to speak to this?
Yeah, so CPG islands they call them promoter regions on the genes, and it's really a location that our partner company, their TD, sorry, they use that to measure the methylation. So they're
Mm-hmm.
measuring on-off switches, right? And methylation represents that off switch. The CPG island is where they're actually finding that information
Mm-hmm.
within the chromosome. So it's really a very complicated thing, of course, but it's really, I was only speaking of it in terms of where they're
Yeah.
finding this information
Yeah.
that they're actually basing it all off of. And it's
Yep.
cytosine, something guanosine.
Mm-hmm.
I was pretty
Yep.
close there.
No, no, totally. It's a kind of audience, think about it almost like if you're looking at your genes like a map, think about these CPG islands as kind of major intersections, right? Not all intersections are the same. And so technology will kind of focus on that. And what the testing is, it's really, really intensive pattern analytics. We do not yet have science to say, is this gene, singular gene, turned on and off? But what we can do is we can go to these intersections and ask the question of, does this show foot traffic of a lot of inflammation? Does this show foot traffic of, really poorly regulated blood sugars, et cetera? We can ask those questions at those intersections and we're able to see the patterns there. And the patterns are what tell us, you know, this is especially from an organ system perspective, right? Is your immune system the cause? Because we see a lot of bad immune traffic at certain intersections. So that's what all that is for there. All right. David is asking a question of us. How does the blood work biologic aging testing compare to the gene aging? So he's saying that blood work age test jumps around based on my blood markers. Okay, so I'll jump into this one, and I'm going to clarify the question, David. I hope I understood it correctly. Um, there are many different companies right now that are trying to qualify, quantify aging. Okay. Some look at DNA, some look at blood, and ours, I'll be honest, looks at both. So from an aging perspective, right, like the biologic age is compared to calendar age, as well as the rate of aging. all of that comes from this pattern analytics, as well as to a certain extent, patterns of, do we see evidence at the intersections, DNA evidence of inflammation of blood sugar, whatever it might be. Additional to that, and I think this might be what you're getting at with your blood question, and this is what a lot of the studies, when we talked about all the metabolites that gave us that information, we have 2 aging bursts. A lot of that blood work can be done to analyze the metabolites, and certain metabolite ratios and patterns, etc., can lend to different aging, in particular our certain organ systems. So my advice here would be, ensure when you're doing aging tests, you're always doing the same company or the same offering of an aging test. Because again, remember, I just talked about a lot of pattern analytics, patterns of genes, methylations on genes, patterns of metabolites. The algorithm that interprets this is really, really, really important. It's still a new science. Is it an exact science yet? Absolutely not. So you want consistency between the different tests. So always going with the same company will give you that consistency between the tests. Okay. And so again, different companies will kind of assess different ways. We do it both ways because I think right now there's a lot of value to both, right? To this DNA analysis, and also separately what is going on within the metabolites in your body. So I hope that was a helpful answer. If you're looking to get tested with us, the really fun discount code is DNA Donut, or Donut DNA. They're going to put it in the chat, but it made me laugh. I think it was delightful, and I'm jealous I didn't think of it. All right. Okay, so Denise is saying that they got their DNA aging kit when it was first available in 2023, and then unfortunately got COVID. And so it sounds like they probably held off on taking it. Can you still use that kit? Denise, I'd suggest just reaching out to us. Different devices will expire at different rates, so we'll just need to check at has your device expired or not. So I don't know the answer to that, but if you reach out to us at client.care, we can support that. And I see also someone, one of probably Vanny or Katie, they might reach out to you and support you with that as well. Okay. All right. Stephanie has a question. Stephanie is saying that she's been hearing a lot about NAD lately, and they haven't done a lot of research, but was curious if NAD would be helpful for genes or to the end of, supporting longevity. And also looking at kind of some other NAD variants. So Justin, maybe do you want to talk to the audience, explain what NAD is, why Stephanie's bringing it up in relation to aging, and what your thoughts and your counsel on that is?
Yeah, so NAD is what we're really talking about is the mitochondria, right? And it's a very important part of something called the Krebs cycle, the electron transport chain, all of those things that make energy within the body, right? That's what the mitochondria do, among many, many other things. I encourage you to watch our mitochondrial webinars as well, because we went pretty deep about NAD and the different precursors and sirtuins and all the fun stuff associated with it. But in brief, I mean, it's a coenzyme that's really associated with energy metabolism and DNA repair. There's a lot of different things that it does. With regard to the genes that we look at, I mean, we do look at things that are associated with the DNA, but not the exact metabolism of NAD or its precursors. We certainly look at the SOD2 pathway, right? And that's really of relevance for mitochondrial health. My opinion is that NAD is going to decline likely on its own over time, and you may want to add some support in there. There's a lot of ways that we support the mitochondria, and NAD precursors is one of them. NAD, the molecule itself, is big. Like, you can't really, people will do intravenous injections and things like that, but it's really something that you typically want to rely on the precursors more so. And there's more or less expensive options to help up and top off your NAD levels. Like, the more affordable options would be like B3 and D-ribose. That's like, probably the most cost-effective way to help elevate NAD levels. And there's tiers and tiers to it where you can get all the way up to things like peptides, like 5-amino 1-MQ. There's NR, there's NMN, and to me, it's like using a combo of some of these things can be very useful. I have seen a lot of people get success with different, energy levels and things
Mhm.
like that. I think NAD is pretty relevant for the overall functionality of the mitochondria, and I think it's a worthwhile thing to support and upregulate. What do you think, Dr. K, about NAD?
Yeah. I think quality is going to be something that's really important there. There's going to be a huge variety of companies offering it. And I would really look towards, unfortunately, one of the more expensively priced ones, because it is a more difficult compound to extract and stabilize in a supplement form. So this isn't something you get to cheap out on. Um, I would also really encouraging understanding your methylation pathway and ensuring that's properly supported. There's an element of you can toss a really expensive supplement in your body, but if you don't have the foundations, methylation set up, minerals to support your mitochondria, there's nothing really for this cofactor to work upon. So I would say even before you get to the point of spending good money on a good supplement, on a good precursing cofactor, ensure that you have your base and your foundation ready. Because otherwise you're just wasting money. So when people ask me, should I be taking this? I always do that foundational work before they get the privilege of adding in an expensive supplement. So that would that would be something I would encourage. If you need support interpreting your DNA 360 to that end, don't hesitate to reach out to us. Yeah, um we're in the supplement business, but we're very careful with what and how we recommend. We tend to take people off supplements, if anything, not
Yeah.
encourage more. Yeah. All right. Ooh, Justin, David has a question for you, sir.
Yeah.
And I think you flirted with it, so let me know if you have anything else to add. David is saying, what do you think of rapamycin for regulating mTOR pathways and cellular senescence? Maybe Justin, you want to offer the audience a definition of cellular senescence.
Yeah.
Um, and they're saying that they took it and it actually raised blood pressure. So David, you might want to chat with your doctor around that one in particular because we don't, it's difficult for us to counsel on the why. But Justin, if you want to kind of dig into why David was doing that and what cellular senescence is.
Yeah, so this is really relative to that last piece that I mentioned before we started the Q&A about mTOR versus AMP kinase pathways and that natural feast-famine cycle that you would achieve via fasting and things. Protein suppression. I mean, there's a lot of things that you can do to help kind of achieve that state. Some of these things like rapamycin, they're really designed to achieve that state pretty quickly. And there's
Mhm.
going to be some benefits to it, right? I mean, mTOR inhibition is got its benefits. And then, senescence and cellular senescence, that's when you hear the term zombie cell, like that's what
Mhm.
that is. It's like cells have a programmed cell death, and some cells, they accumulate as you age and they don't die, but instead they accumulate and they'll release these inflammatory compounds in the body. Right. So that's where you need to do certain things to trigger what's called apoptosis. That's like programmed cell death. And it helps get rid of zombie cells. So if it's a zombie apocalypse, apoptosis is basically the flamethrower that can go in and help wipe out some of these zombies. There's definitely ups and downsides to a lot of these things. Like Dr. K said with metformin,
Mhm.
it's like there can be some benefits, but it's also probably not the first thing that I would recommend. There's a million
Mhm.
lifestyle factors that I would add in first before I would go towards these things. And I have seen people just like in your boat who have had issues with it
Mhm.
because there's also immunosuppressant qualities to it
Mhm.
naturally. You can also over moderate mTOR, by the way, and that's part of my problem with metformin. We don't want to lose muscle mass. Sarcopenia is a huge problem.
Mhm.
We want to initiate some of these things, apoptosis, and we want to initiate AMP kinase, but we don't necessarily want to do it artificially right off the bat. I think we want to kind of
Mhm.
hash out the natural ways of going about it because
Mhm.
immunosuppression, is a huge problem as well, right? And that's possibility with things like rapamycin. So it's a tool in a toolkit that you can use. I would not do it unless I was under a doctor's guidance personally.
Mhm.
And being a primal guy, I just can't really recommend drugs. It's much easier for me to say, let's practice some intermittent fasting and see if we can do it the natural way first. And like I say, there are great
Mhm.
ingredients out there like spermidine and things that act as
Mhm.
these fasting mimetics, and it means that you don't have to do these big, long fasts to get some of the
Mhm.
benefits of it, right? Like you can eat normally and take things like spermidine and give you some of the autophagy benefits and things as well. So I'm a fan of some of these ones that are a little bit more, I think, safe on the body,
Mhm.
but you do you. I don't necessarily have anything against it either, right? But it's something I would have some guidance surrounding before using it.
Yeah, absolutely. Absolutely. Yeah, I think especially for people that have fun playing in this space, maybe drugs are the perfect, like, maybe that's the perfect solution.
Yeah, it's a fun space, like it's
Mhm.
okay to be experimental with some of these things. I just can't recommend it as a practitioner, but grown adults are allowed to do whatever they want.
Exactly. That's the delight of the world. All right. Susan has a question saying, do you recommend fasting if you have a dysregulated insulin gene? So, Susan, you're probably talking about TCF7L2. And I want to make sure we're very clear about this. If you have a suboptimal TCF7L2, meaning you do not optimally produce insulin, which can in turn lend to insulin insensitivity, which can lend to diabetes, etc. This does not mean you're going to get diabetes, right? Um, what I really use genes to gauge in this instance is in if you were eating a horrible diet, you were eating sugar stop to start of the day. That was all you were eating. What your genes will tell me is how quickly you're going to get diabetes. They will not tell me, will you get diabetes? So remember, if you have a bad presentation, it does not mean you will. It just means that in the right circumstances with that bad diet, you're going to get a lot quicker than someone who has an optimal presentation. Okay. So would I recommend it? Maybe, maybe not. I think we'd need to do blood work and lifestyle work to understand, do you actually have dysregulated sugars? Is there something we're trying to treat? I think fasting's a wonderful thing for many different health outcomes, including, right, insulin. But I'd really want to work with a practitioner to understand, is it appropriate for you? So what do I mean by that? Um, Sometimes women, people who are menstruating, fasting may not be appropriate for them because of the fluctuation in hormones. That needs to be taken into consideration. People who have chronic diseases, sometimes it can be used in supportive treatment, but oftentimes body might be too stressed to undergo fasting protocols. So while I think in general fasting is a great thing for a lot of people, check with your doctor first, especially if you have either of those two things, a chronic illness, or you're someone who's still experiencing their menstrual cycle. Because can you still fast in those instances? Yes, but you need medical supervision and support there because we want to make sure you're doing it properly and to the end of health. All right.
It's a heck of a balancing act, this whole fasting thing, right? Like we want to make sure that we're
Yeah.
not providing too many scarcity signals to the body either, right? So we
Yeah.
always have to remember that epigenetic input, what's
Yeah.
this going to signal to my body? And if we overdo that, then you can
Mhm.
have a lot of downsides as well. It's pretty much a hormetic stressor, as we know. So
Yeah.
any
Yeah.
hormesis can be overdone, including fasting.
Yeah. 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 All right. V is asking our next question. Um, what is the optimal allele presentation for the two genes that you mentioned? One was TCF7L2, and they didn't know the other, but I would suspect it was probably APOA2. So TCF7L2, you're looking for G. G as in Gregory across the board. So GG, that's the optimal presentation. For APOA2, Justin, hold me honest, it's A's. Andrew, Andrew?
Yes, I believe so. This is the hardest thing, just so everybody knows to remember. It's the alleles are the hardest thing to remember in
Yeah.
functional genomics because it's C's and it's G's and it's T's.
Yeah.
Um, Out of all of it, like I can remember the names of the genes, but that's the part I struggle with the most is remembering um, which one is which because when I'm with patients, it's written down right in front of me. I know what it
Yeah.
all means, but it's like, is
So
it a G or a T? It's tough,
I
tough to
just
remember.
looked it up to confirm because audience, we want to give you good advice. A is in Andrew, Andrew, Andrew is the optimal form. So for TCF7L2, you're looking for Gregory's. For ApoA2, you're looking for Andrew's. Okay.
Yes, good.
And we always double check because I think we probably know most of them off the top of our heads, but there's going to be that moment where we don't and we give you wrong letters. All
Yeah.
right. Uh, Okay, so Elizabeth is asking, can you please speak to the role of pancreatic enzymes, the health of the pancreas, and how fasting and other diet adjustments can influence them? Yeah. Oh, you extended it beyond insulin. Justin, do you want to take a go at this one? Some of the enzymes there?
Yeah, so I mean, these some of these enzymes, I mean, they play a really big role in how your body digests different foods, right, in the
Hmm.
intestines. Um, it's really I always look at it and I come at it from the perspective of like macronutrient layout. And usually I'll recommend like a little bit more of a protein heavy diet as opposed to some of the other ones that are a little bit more, insulin secreting. Um, as far as the specified enzymes, I don't know a lot more beyond what the TCF7L2 suggests because that's like the master regulator of what the actual
Okay.
mechanism looks like. Um, I don't have a particularly intelligent answer as to the more zoomed in perspective. I'm just being
Yeah.
humble today.
No, 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 that's good. So when we think of, I would speculate a lot of the enzymes you're referring to are help digestive enzymes, and we're getting some from pancreas, we're getting some from uh, gallbladder, and so really, I would offer when we think to the end of how do we digest properly. So we want to think about being in more of a relaxed state. Quite literally, being in a relaxed state supports secretion of these. If you're a little more tense, you're not going to get the same secretions. Okay. Some people will find more acidic things will help spur them on. So think about this, like when you start salivating and getting excited about food, your stomach actually starts creating a little bit more hydrogen chloride, which is acidic, to encourage more secretions there. So some people find kicking off a meal with something a bit more acidic or sour will be helpful. And sometimes people who are like, oh, after a meal, I don't feel great. And then I have a cup of coffee, or then I have like a sour drink or a salad or something where it's a little bit more bitter inducing, right? That's to the end of, again, encouraging that release. For the herbal nerds out there, you'll see a lot of bitter tinctures, which are really bitter, bitter herbs that if you take that before a meal, again, that bitterness encourages the release of that. So to the end of resetting that, I think it's very specific protocols if you have medical conditions. And so I'd want you to talk to your doctor as to what you're trying to reset, what the problem is, because different protocols can support that. But you really, really, really do need doctor monitoring for that. In particular, that more insulin reset one that I mentioned, you need to be observed by a doctor for that. That's not something you can do on your own. Yeah.
Good answer, Dr. K. Thank you.
No, of course. Of course. All right. Um, so Talia is asking the question of what would you recommend for someone um, who has poor carb and fat metabolism? So we're talking about TCF7L2 and ApoE2. So Talia might just have this is a general question. They actually said it wasn't specific to them, but for someone who's suboptimal in both of those genes, Justin, you have such a beautiful answer for this. So I'll allow you to dive into it because I can appreciate, and we get this feedback sometimes. I know I'm definitely someone where my genes are like, you can't eat anything. What's the solution? Because eating air is not what we're proposing people do. So if someone's suboptimal in both spaces, what should they be doing?
Well, first of all, there is ways that you can improve the metabolism of both of those things, right? I mean, for example, with carbohydrates, like if you're suboptimal in your ability to actually process them, then you may want to just time it as like a post-workout meal to get a little boost of carbohydrates. Because you've just burned through your glycogen storages, and it's a lot less likely to cause, blood sugar dysregulation and things because it's going to go towards the reloading of that glycogen. So timing of carbohydrates, type of carbohydrates, volume of carbohydrates, like how many grams really is it? A great trick is to turn rice into a resistant starch, right? Like cook it and cool it. And it's a lot less problematic there and more digestible. What I would also suggest is that, I mean, the general theme or layout of your food will probably be some, low glycemic veggies coupled with a decent chunk of protein and just letting the fats naturally occur, but not going out of your way to add them in,
Mm.
not a ketogenic approach or an on purpose high fat approach. And what I would say as well is that the types of fats there matter, right? So if we're suboptimal for ApoA2, we're going to want a decent blend of the type of fatty acids that you do take in. So it'll be a little bit of saturated, a little bit of monounsaturated, a little bit of omega 3s thrown in there. But none of these things are like on purpose choosing the fattier cuts of the meat, right? You're going for the leaner sources there. And then you're just letting it kind of naturally occur, but you're not basing your diet on either fat or starch. Protein would likely be the more constant macronutrient there. And then we're just trying to give you enough fat to fuel your hormones, to fuel your brain, and enough carbs to fuel athletic performance and allow you to sleep properly and stuff like that. You can take in enzymes, you can use things like L-carnitine, you can fast, you can really modify. And that's what we work with people on. Like I've had plenty of clients, I'm sure you have too, Dr. K, where it's like, what can I eat? And it's like, well, let's work on that a little bit because
Mhm.
veggies, a lot of them don't have either of the above, right? And you can get
Mhm.
micronutrient sources there. Protein, you can get leaner cuts, and then you can do
Mhm.
like carb cycling. You can
Mhm.
manipulate the carbohydrates based on activity levels and different things. There's also different types of carbs than starches, right? There's things like fruit. It's not a starch-based carbohydrate. So there's differences there, and really we just create the best case scenario with what you can eat, and that's all we can do.
Mhm. Yep. Yep. I like that. All right. Our last question, and I'll field this one, is from Lynn. They're saying that when 23andMe ran their APOE, they had one presentation. And when the DNA company ran it, we had a different, namely, one allele was off. And so just asking for commentary on this. So, Lynn, unfortunately, this is a common problem that we see in part because a lot of people have run APOE. Um, the gold standard, the gospel truth of what your genes are is something that would be called DNA sequencing. This isn't by and large, it's becoming a little more commercial, but historically, as in like a few years ago, it was something really you only could go through a hospital and it would quite literally go in and map every single allele you had. And that was considered the gold standard. That would be the gospel truth. Most companies, and this includes DNA company, this includes 23andMe, they'll go in and they'll read sections of your DNA at like it's kind of like taking a chunk, reading that chunk. And we're really good at it, but it's not the gold standard, right? And so when it comes to APOE and why there's a lot of difficulty, and sometimes we get a lot of reports of like, hey, we have different presentations, is and I'm not going to get too deep into the technicals of it. It's on a really difficult to read part of the DNA, and all laboratories struggle with it. It's not specific to us, not specific to another company. It's just when you go in and trying to only read a little bit of it, it's in a twisty, difficult part to read. And so you'll sometimes get companies competing. It's really difficult to compare apples to apples because unless you have the lab nerds from both labs comparing their protocols of how they read that gene, it's really, really difficult to understand who's right in that kind of very truthful sense. What I can say about our testing, because I'm very proud of it, to the end of ensuring we get the best and most accurate picture of what we're doing, we have a few things in place. First and foremost, we do a read and then we do an additional 6 probes, kind of think of 6 extra tests to validate what we're doing. So we kind of read the gene 7 different times. That's roughly true. Okay. Additional to that, we also do something called call rates, meaning when we read people's genes, we don't release anything unless the call rate, the validity, the certainty we have is over 98%. Scientists, by and large, are very humble creatures. We never say 100%. So, us saying something is 98 or 99% positive is as close to 100 as you're ever going to get. So we have a lot of checks and balances. So are we very confident in our results? Yes. If you want us to kind of do that deep dive, look at your sample, know what the call rate was, we can absolutely do that for you. Just reach out to us and let us know. We typically like to have a bit of insight as well. So you've offered like it was this company, it was this year. That's helpful because also remember over time, laboratory processes get better. I wish this was something where, like, it's every 5 years they get better. I'm seeing laboratory processes get better every single year. So there's an element of the recency of the test is also really helpful because, again, we update protocols at least once a year, if not more. And so that makes them more and more accurate. So I hope that was a good answer to your question. I see it a lot, so I'm grateful I got to kind of dig into the murky laboratory side of it, because a lot of people it's black box magic, and I like when we get to pull up the sheets a little bit and show you the magic underneath. Yeah. So that was a happy way, I think, to end a discussion of aging, because
Yeah.
APOE is so important when we talk about cognitive health.
Yeah, absolutely. I mean, I there's no one gene that represents how you're going to age, right? I mean, every one of these things is controlling how your
Mhm.
cells are functioning. So, what
Yeah.
gene that we test doesn't contribute to the aging equation? The answer is
Mhm.
all of them are relevant and all of them matter, and it's part of a total picture. So give each and every one of them their due respect and understand how they all have
Yeah.
interplay with one another, and
Yeah.
that's going to give you the best possible ammunition to age gracefully and go out there and happen to things, like I said earlier.
Mhm. Yeah, I love that. And I'm grateful for that messaging because I think a lot of people come in and they want one quick fix. They want one gene that will tell them when they'll die, or they want one medication that will fix it all. And unfortunately, it's not so simple. We're not going to be able, as much as we want to. We've tried for a long time, and we've learned the answer is no. You cannot boil it down to lesser than what it is.
Yeah, there's
So
way too much going on with the body. Like, how many things did I talk about tonight? And then that pancreas question came up, and I was like, "Pff, that's not in my brain right now." So it's because of how complex it is. You know what I mean?
yeah.
So we really try to seize control of as many areas as we can. And it's a continual process. We all learn together, and I'm grateful for it. And I'm grateful for you,
Mhm.
Dr. K.
You as well, sir. You're always dropping the wisdom, and I'm grateful for it. And I think the last wisdom that we're going to drop on our audience is a little bit of a dance. Audience, in case you don't know, and I encourage you to join in, we always dance out because we know that exercise is incredibly important to mental health. And there is a happy little study that said, of all the exercises, what is the best way to prevent and support mental health? And it is dancing. So we always dance out because we want to encourage you, just like we want to encourage within ourselves. Um, why we try to stay healthy. It's to the end of feeling great. So we shall dance out. Audience, it was amazing to see you. We are back again tomorrow and then as well on Thursday. Justin, I think you're on tomorrow. What are you rapping about tomorrow?
We are talking about mold. We're deep diving on mold. One of those things that'll make you age faster. So we got to do something about that one. So
Mhm.
I'll see you guys tomorrow. And then I believe Dr. K is going to be killing it here on Thursday.
Yeah, I'm doing menopause. So we're going to be talking all things female hormones, and we're going to be discussing what exactly it is and how passive or active you can be in that journey. Mhm. All right. So between Nikita and myself, we wish everyone a delightful evening. Justin, sir, always a privilege and a pleasure. We'll see you soon.
Ditto. Thanks everybody for
Au
showing up.
revoir, mes amis. Au
Bye
revoir.
bye.